Thank you so much for the invitation to speak today, and I'm pretty excited to have an opportunity to reflect on the year with everyone. I know that this is a big talk and sort of a big session, and so I'm just going to get started. So these are my disclosures. I will be talking about some of the work that is funded to look at COVID and creating data sets for artificial intelligence. And so I was looking through my talks and I found this picture here. This is a picture on one of the biggest slums in Kenya called Kibera. And, 1 year ago, actually, I was invited to speak to a forum for techies looking to actively get involved in AI development. The talk that time was titled AI Beyond Radiology Images. And, I remember sort of pleading, at the end of my talk that if I could even appeal to a single person to join the community to start to think, because there's really smart people out there in technology and medicine, and to motivate them to bring their collective minds to tackle this sort of pandemic, which was a big, difficult a problem. And I have to admit that there was a little bit of desperation, in my voice as it was in the midst of pandemic. And so this is my picture actually very earlier on. I think you remember that, sorry. So this is my picture very earlier on. This is my first bag of PPE that I received. It was reusable. This was unimaginable to think about in the US. It had my N95. Yeah, every time I used it, I had to put it back there. And I remember, sort of talking about, sort of undergoing through, preventive protective equipment shortage, this under testing that we really didn't know who everyone who was infected, thinking about whom to prioritize and playing a little bit of God, trying to prioritize which patient got care, and also just the fear, the stress, and the burnout of just trying to take care of patients that he couldn't really care for, and even colleagues to see them when they were getting sick. And also there was issue, new cohorting, staying at home, new workflows for cases that seemed to be very direct and very easy to do. I felt that I was just overwhelmed and just under the water. And so at that point, I said, well, and you would agree that the focus was on screening. Most patients were asymptomatic, and at that point, people would say that AI is better at things that we radiologists are blinded to. We were having even collaboration between Google and Apple for contact tracing, thinking about resource allocation, who will get a vaccine, and even starting to see the second pandemic that we saw throughout the last year, at least in the US, where we saw disparities around racial injustice, and not just in the streets because of police brutality, but also around healthcare provision and disproportionate deaths between the Hispanics and the Black patients. And so, at that point, I remember working with some of my students. We ended up, penning this, commentary about sort of how would AI and chest imaging, help. And we were thinking about helping with diagnosis. There was quite some work around disease trajectory, aka the corona score, to even get imaging correlates and even start to think about a personalized drug choice with imaging markers. But wait, my talk is about the EN review. What's been fantastic, and I mean, I'm so happy and so lucky to actually have received one of these vaccines. I hope you are, or you're on the way, is that we've had tremendous amounts of vaccines developed for the pandemic in less than 1 year, and a lot more in the pipeline. And so that's been, a super win. And if you think about the problem that I talked about, screening and being able to test, we've seen quite a scale up of diagnostic testing with new companies. You now know that you can use saliva for testing. I mean, you can't even have a meal at home. The other day I went to the store and there was actually a test at home testing. But the reality here is what's happened with imaging and what's happened with, I will talk specifically about chest x-rays, because chest x-rays is a workhorse of radiology work. And that's because it allows for rapid triage. It's available and accessible. Remember, the chest x-ray machines can be moved towards the patient. And so there was a lot of hope and enthusiasm to think about chest x-rays as a solution, and when interpreted with AI. And so what we started off, we started to figure out how do radiologists, study, and how are we, because as radiologists, we're also starting to see new patterns of disease. So how good were we in terms of interpreting this? As you can see on the left chart, that you see there's quite a lot of widespread, and these are the COVID positive patients. So we had 10 readers across 5 institutions, and you can see that the bell shape of the plot is pretty wide, showing that we don't really have good consensus for the RT-PCR positive patients. Sometimes we say they're normal, sometimes it's COVID-19, other times it's other infectious and other non-infectious. But it was very clear that we were very good at identifying COVID, negative patients, at least on imaging. And we knew that people were presenting with different respiratory system, complaints. And so if we looked at the performance of the radiologists, then we would see, if you look at the chart on the right side, you can see we're pretty good at identifying normal when there is RT-PCR, negative, and what would be a normal X-ray. But when it comes to positive, where they have all symptoms, at that point, radiologists were all over the place. And I'll have to say that this was just because we did this study very early in the pandemic. And if we thought about it now, when we've understood what this looks like, it will be much different. And so we did see quite some work on AI for COVID, especially with the COVIDNet and the CoroNet models. You can read about them. And this came up pretty early, also came up with COVID data sets. And we were excited, at least in our team, to even test out some of, because they were in the open source domain, test out what that meant in real life. And so we had an Emory data set at that point, which was around 1786 COVID positive patients with a mean age of 55. You can see that Atlanta has quite a lot of Black patients. And so our Black population was very well represented. And so we compared also this work a lot with 3 public data sets, the CHEX Expert, CHEX X-ray, 14 from NIH, and the Mimic Chest X-ray. And what we found was that, honestly, these models were not useful, despite reporting very high sensitivity and specificity. And this is because on the Emory dataset, we had very high false positive rates, with COVIDNet, and very high negative rates with the CoroNet. And with these other 3 datasets that had never had any COVID patient beforehand, we actually saw that they were identifying COVID patients, which should start to show us that there's quite a lot to understand. Not to make this useful, honestly, our team decided that this would not be the biggest return on investment, but to understand how this AI algorithm worked in real life. And so we at Emory ended up training our own internal model, which was a ResNet model, and using pre-training using the public domain data sets to normalize the weights, and then locally fine-tuning on our own data set. And so with this, we ended up getting a little bit of a better improvement with an accuracy of 85%, and an F1 score of 0.86, which was much better than what we had received from the public domain. And so, we could say that maybe every institution needs to build their own model. And when we looked at the subgroup analysis on race and gender, we didn't really find quite of a discrepancy in terms of the model performance, at least with the model that we train now. We have to note that we actually have a lot of Black patients. And then when we look at some of the misclassified patients, like this false negative, this is an asymptomatic patient, which brings back the effect of ground truth and what that means. And so when we went back and compared the performance with the radiologists, we found that the radiologists, again, are very good at identifying the COVID negative patients, but very poor at, the model was much better at the COVID positive patients. And then thereafter, we took our model to other places. And this was sort of like where we are, where we had good performance internally, and on an external data set from the Midwest, it was pretty much like chance, very, very poor. And on the public midweek data set that's being collected by the NIH, which only has positive patients, we had a higher F1 score. And we actually ended up having this model available through the Society of Imaging and Informatics in Medicine, to the public domain. And we also got a good score. So we were wondering, okay, why did we fail for this other second place? Now, I would say that what we observe overall is that we've not, despite prime time for testing, prime time for vaccines, prime time for COVID AI models is not prime. This is a site that tracks all the medical imaging models by the American College of Radiology, and we don't see any model presented that even has been approved for COVID testing by the FDA. And this recent paper here that talks about AI for COVID 19 starts to show how these algorithms fail and why it's pretty concerning. Let me show you an example. They use generative adversarial networks and saliency maps to figure out where was this model looking. And this is a really interesting paper to start to highlight some of the challenges that we see when we deploy machine learning in real life. As you can see, it looks at the corners, and the shoulders. And we all know that COVID is primarily within the parenchyma. Now, just because it's not prime time doesn't mean it's not being used. The EPIC EMR system has been pushing out these models. No one is able to validate them. We don't use it at our institution, but I know that this will be coming near us. And even AI could not even get the vaccine rollouts. This is coming from one of the biggest places that has giants in artificial intelligence and couldn't get their vaccine allocation right. So the score, at least for screening and early management, I think is in the red here, really. And so I don't want to end up with this negative note, but to highlight sort of one thing, which is where is the future? This is a mirror back home, again, about COVID, and these are all over the place, and I really like looking at them. And we start to see around severity and this long COVID syndrome is where maybe AI in radiology and will start prime time, and so we start to see that we can use natural language processing for ICU, transfer in hospitalized patients and get quite some good results. We start to see that we can start to use not just medical imaging data, but EHR data to tell us which using fusion models to figure out which are the most significant features that we can focus on for research. And you can see in this case, CPT codes and ICD codes contribute the most in terms of predicting hospital utilization. And this paper was really looking at, will you get hospitalized at the time of testing? And you can imagine such a use as you deploy these AI systems and the testing systems at home. More importantly, I hope that next year we'll have like a summary of this, is to help us to look at the biases in the context of how we provide healthcare. This is some of the work that we've done to start to show the discrimination of ICU scoring systems. And we note that they overpredict mortality for Blacks and Hispanics. And systems that is used primarily and was used a lot to track whether people are going home, which is the pulse oximetry, is very biased against Black patients. And so I, again, appeal with a different type of desperation, again, to try and make sure that these algorithms work. But in the year 2020, AI in COVID, I think did not do very well. Thank you so much for the opportunity to present. This is my team at Emory, and please do reach out. Thank you so much.
Thank you very much, Judy, for a very insightful talk and for explaining very well the limitations of AI, of the use of the artificial intelligence in a medical setting. So we have now a couple of minutes for a few questions. And the first question is really, do you think that the limitations that you just described and the negative results, in a sense, will increase the skepticism of the medical community towards the use of these tools, of the technology also for the future? So do you think that in this sense, the COVID-19 pandemic will lead to an increased skepticism against artificial intelligence now that we see that there are big limitations in the use of these tools, or instead there will be still an enthusiastic approach in the future?
I would like to say that a few things. One is that the infrastructure did improve, so where it was difficult to get healthcare systems to start sharing data, even investing in infrastructure, that improved. And so just by that, I believe that that's a win from this, last year. I agree with you. Maybe the computer engineers will start to see that, AI in medicine is very hard. And so maybe that humility is going to encourage more diverse and interdisciplinary teams to try and get together to be able to work together to actually reduce this, oh, this is hype. But I can tell you for sure, given how many incentives there were, and seeing what other technologies that we've adopted in this year, using Zoom for telehealth clinics never would have been possible in the past before the pandemic, using FaceTime at one point for Zoom visits. And I think that what we see here is that we have a chance, honestly, to build interdisciplinary teams. I'm not going to give up because I think the real work is just beginning to start now. And I hope that people will just take the humility that it's really hard to do AI in medicine. This is a very simple task. The radiologists are better now, but the AI still remains the same. And we know there's quite a lot of teams that have worked on this.
Yeah, thank you. I agree with the idea of working interdisciplinary teams, and of course the role of medical doctors here is fundamental. And on the other hand, you explained very well the risk of bias towards unrepresented communities in using these tools. Do you think there's enough awareness regarding these issues in the medical community as well, and also in the machine learning community? So about the fact that, as you explained very well, machine learning tools may very well be biased towards more represented communities, and then miss the results in the case of vulnerable or underrepresented groups.
Yeah, I think that's a really good question. I think the work around bias is very earlier on. And two things have sparked that. At least in the US, it's the death of George Floyd and sort of this uprising movement that it's not just by blacks, it's about, multiple race groups. We've seen the violence against the Asian community. And so people now, I think, are more cognizant. But I think also that the system was a little embarrassed and shocked at how, this discrepancies in sort of this pandemic. And so not just because of AI, I think there's a big focus right now on, by the federal government, like with the Unite, initiative by the NIH to focus on racism and health disparities. And so I think we will see just in the medical community for us to talk about that. Now, when it comes to, I think there was an editorial, last words, some of the incentives that are there, which is to, encourage public data sharing, is going to bring up some unintended consequences where, people will start to see patterns that some groups are not cared for in the same way. And so there has to be not just a technology solution, but also a society solution that brings advocacy and removes the shame or the embarrassment that will make people not participate. Because what we're starting to see is that actually the AI itself has implicit bias, and it's very trivial. It's not very, it's not very obvious. For example, like when I say this algorithm is biased towards a black, inmate, or someone a black person who requires a bail, because I can see some of those things. But when it comes to medical imaging, it's very subtle, and that I think can be a challenge. So the long answer to your question is to say that we've not really had a consensus on what exactly is fairness in this. When I approach my work, I pick up some technocentric tools, I pick up some clinical, acumen tools that I try to figure out this doesn't make sense, or the model could be looking at this, but these type of audits are not standardized that would allow us to even be able to benchmark what's the severity of the problems. We just have to remember that the data sometimes we use is not representative of our population. And also remember the people who are not represented in the data because they wouldn't come to hospital or died at home.
And we have one question from the audience regarding the performance of your model on the external data. Have you tried to understand with some explainability technique if there were some visual features that were tricking the algorithm, giving the poor and to explain the poor performance on the algorithm on the external data sets?
Mm-hmm. Actually, we are in the process of doing that. We have two now new external data sets. We just had one. Initially, we thought it was a pre-processing problem, honestly, but it's not a pipeline problem. Then we moved on to think about sort of like the distribution and, the equipment that would be sort of like this are more like radiological things. The things about when we use medical imaging, honestly, the last paper that I showed, they used generative adversarial networks and saliency maps, but we know saliency maps are terrible. If you just or change the order of your training or your the way you present your x-rays, the saliency maps are off. So those are really poor in terms of helping us understand what's going on. And so most of the time has been just sort of like having consensus, looking at some samples, and then retraining the model. So we currently are now reviewing some of the performance, but what we explored earlier on, we couldn't figure out why the model failed so much on one data set, versus the other data sets. And that's some of the work that we're doing.
Well, thanks a lot for your answers to the questions, and thanks again for your presentation.